And good evening. Welcome to the Carolina Weather Group. It is May the 29th, 2019. I'm James Brierton in Charlotte. Welcome to episode 279. We can't believe it. We're so happy you're here, and we're so happy that you're withstanding all this heat with us. The heat wave continues here in the Carolinas. You can see the current temperature scrolling at the bottom of your screen. We also have one severe thunderstorm warning to tell you about right now, and we'll show that to you here coming up momentarily. But that's just outside the Raleigh area, and I think maybe in just the last few moments, that was allowed to expire because as we pop up statewide radar here, I'm not necessarily seeing it anymore, but if it was, I think it is north of Interstate 85. So that will be for a threat of damaging wind and some hail moving on through, but it's just one warning right now. Otherwise, for the most part, as everyone knows, the big story here in the Carolinas has just been the heat and how dry it has been, despite that isolated rumble of thunder or so. We will talk about not only that heat wave coming up in the 9 o'clock hour, but take a look at this. This is fresh video in from our Storm Chase crew. The Carolina Weather Group Storm Chase Week is underway. We've got panelists Chris Jackson, Scotty Powell, and Evan Fisher out chasing in the Central Plains this week. You've probably seen their Facebook Lives. Well, they've just sent back new video into our control room, and we will have that coming up at 9 o'clock Eastern when, fingers crossed, they will be joining us live from the road. I think right now they're either in Texas or making their way to Texas, so we'll get a breakdown of that coming up in the 9 o'clock hour. You're not going to want to miss that. But let's get tonight's conversation started. We'll be looking ahead at the tropical season. The hurricane season is going to begin here in just a matter of days, so let's go down to Charleston, South Carolina, where Shay Gibson is going to start us off. Shay.
Yes, James, thank you very much. We have Dr. Philip Klotzbach in with us tonight. He is with Colorado State University and based out of Walnut Creek, California. He's going to be joining us to discuss his Tropics Outlook that he came out with in April, and also one coming up next week, I believe. We're going to be discussing that and maybe some of the things that have changed from the original Outlook. And with that, I'll go ahead and introduce Dr. Phil. And if you would just kind of give us some background, maybe what got you interested in weather and your weather journey as a whole.
Hi, Shay. Thanks so much, guys, for having me. Looking forward to chatting with you about the hurricane season, which I'm sure all of you know is fast approaching. It gets started on June 1st, so just a few days away now. I was actually born on May 31st. I just missed the start of hurricane season by one day, but I was 11 days late. My mom said no way, she was going to wait another day to have me. So just missed out on the start of hurricane season. But yeah, so we put out our first forecast in early April, and like you said, we're going to be updating it next week on June the 4th. I've just always been obsessed with weather since I was a little kid, basically as long as I can remember. My first memories are having my dad print out maps of the United States, and I draw fronts on them and I grew up in Massachusetts, so I was always trying to draw synoptic setups that would make the best setups for snow in southern New England. We often fortunately got a lot more rain than we got snow because those nor'easters would come a little too close to the coast and they changed to rain down in southeast Massachusetts. But yeah, I've just always been obsessed with the weather. And then after my undergrad, I applied to graduate school, several different schools, and I applied to CSU, Colorado State. And obviously, I've been fascinated with Bill Gray and with seasonal forecasting. I've done a couple of projects on him and actually did my undergraduate thesis on Bill Gray's seasonal forecast techniques. And so I applied to go to grad school, and he accepted me. And I loved Colorado, I loved the mountains, and the chance to work with Bill Gray was just an amazing opportunity. So I seized that opportunity, and CSU hasn't been able to kick me out since. So I've been at CSU for almost 19 years now.
Well, that's great. What a great legacy for Dr. William Gray as well. You guys do a great job. We appreciate everything you do, and we really appreciate you taking your time to come on the show tonight. With that, let's go ahead and talk tropics. What's going on right now? We have, it seems pretty quiet in the Atlantic. We already had one named storm, Andrea. And what should we expect in the near future as we start the hurricane season on June 1st?
Yeah, so right now the entire globe is very, very quiet. We have no tropical cyclones around the globe, and they're really not even monitoring any areas for development. And so that's actually pretty typical. Usually early to mid-May is about the quietest time globally for tropical cyclones. So now is about the time you start seeing both the western North Pacific and the eastern North Pacific starting to heat up. But we haven't really seen much there. Potentially in a couple weeks, you might see some more activity there. Right now, the Atlantic looks pretty quiet. The long-range forecasts from like the European Center have a lot of high pressure in the Atlantic, so I don't expect we're going to see anything super significant in the next few weeks there. But obviously, you can get these kind of marginal storms, as you mentioned. Andrea formed last week, and I think Andrea is a classic case in point of what a really, really marginal storm looks like. It was a subtropical cyclone, which is a cyclone that has characteristics of both mid-latitude systems and tropical systems. So it's kind of one of these hybrid storms, and it lasted less than a day. So it was a really, really marginal system. So basically, tropical cyclone gets its energy basically from the warm ocean water, and a mid-latitude cyclone, its energy source is effectively temperature gradient. So a subtropical cyclone is kind of half and half. And last year we had a ton of those subtropical cyclones. We actually had 7 storms that were subtropical at some point during their lifetime, which was a record. But if you're looking back at historical records prior to the satellite era, prior to the mid-60s, there were no subtropical cyclones. They just didn't even name them back then. So it's more of a new thing to name these kind of subtropical cyclones like we had last week.
Understood. So your outlook that you came out with in April, let's talk a little bit about that. What were you seeing then? And are you still kind of holding to that now? And sort of give us a rundown on what you were seeing.
Yeah, so when we put out our forecast in early April, we called for a total of 13 named storms. Of those 13, 5 becoming hurricanes, and of those 5, 2 becoming major Category 3, 4, 5 hurricanes, winds of 111 miles an hour or greater. And while they only make up about a quarter of the storms that form in a particular year, when you take those storms and you adjust them to how much damage they would do today, given today's population and wealth, they do about 80 to 85% of the damage. So they're the heavy hitters, so to speak. And so at that point, we thought we currently have weak El Nino conditions. At that point, we were thinking that El Nino was likely to persist. El Nino is generally our friend because what it does is it increases upper level westerly winds and really increases the vertical wind shear. So the change in wind direction with height in the atmosphere, especially in the Caribbean, but extending out into the tropical Atlantic. And so it really tends to shear apart hurricanes as they're trying to develop. At this point, we still think that El Nino is likely to persist. It's touch and go. There's a lot of uncertainty with that, probably even more than we had in late March. But I think there's some things that have happened even in the last 10 days to 2 weeks that are likely to keep that El Nino persisting for the next few months. And obviously, June 1st is right around the corner, and as Yogi Berra used to say, it's getting late early. So if El Nino is going to die, it's got to go fairly quickly, or if it does wane during the season, the lack of its impacts may be too late to really impact this season. The tropical Atlantic in late March was a little bit colder than normal. Now it's about pretty much dead on normal. Last I checked, it was like 1/10 of a degree Celsius warm. So basically just about normal. And so there's a lot of question as to, is it going to stay normal? Is it going to warm up a lot? Is it going to warm up slowly? Right now, I don't really see any signs that would say it's going to warm up super fast. I'm just kind of looking at the long range forecast, but there is obviously uncertainty since mid-latitude weather forecasts 10, 20, 30 days out in the summer aren't particularly useful. So just because the models say high pressure over the Atlantic for the next 3 weeks doesn't necessarily guarantee that's what's going to happen.
Right. So you also, what changed from the April outlook to now? Are we looking at more storms? Are we looking at more intense storms or less? Or what's your future outlook?
Yeah, so we're finalizing the outlook right now. Literally, I was working on them right before I came on here. And so, the number of storms is probably going to go up slightly just because we've already had one of these junk storms. I don't foresee really any large changes. I think things are tracking fairly similar to what we saw in late March. There may be some slight increases in numbers, but I don't foresee anything too large at this point, just given conditions haven't rapidly transitioned to make things either look more or less conducive. I think things are tracking fairly close to what we thought. And so we will be updating our forecast next week, and then we update it again in early July, and one final update in early August. And while August is 2 months into the hurricane season, about 95% of all your major hurricane activity occurs after the 1st of August. And so even though we're 2 months into the season, typically June and July are pretty quiet overall. Generally you can get landfalling hurricanes, but generally most of them also make landfall during August or October is really the 3-month period where the storm season really ramps up.
And quick question, I know Jared's got one coming here. Where does some of these storms originate from this time of the year at the beginning of the season?
Yeah, so typically in June and July, your storms form further west. So you don't typically get systems coming right off of Africa and forming. They tend to more form in the Western Atlantic, maybe the Western Caribbean, the Gulf of Mexico, sometimes off the east coast of Florida. You can get landfalls this early. Typically, it's unusual to get landfalling hurricanes in June or July, but certainly they can happen. But more the Western Atlantic is where you see your storms this time of year. Kind of just canonically, kind of how you think about hurricane seasons is that in June and in July, basically in June and July, the shear in the Eastern Atlantic is fairly low, but the atmosphere is just too stable and there's too much dry air and the waters are too cold. So that's kind of what keeps the season from ramping up too early. And then what kills the season late is the shear. The shear gets too strong. So September is kind of the perfect intersection of the shear still being relatively low and the waters being warm enough and the moisture being high enough. This is the time of year you see a lot of dust coming off of Africa, which is a classic sign of a lot of dry air. But one of the things that I always talk about with the dust is just because you see dust in the Atlantic doesn't necessarily mean that that's a quote unquote bad for the hurricane season, because very, very vigorous easterly waves coming off of Africa. So the seedlings for hurricanes often bring strong dust outbreaks with them. So when you have strong easterly waves, you have strong thunderstorm complexes bringing off the dust. And that's actually a sign generally of a more active season. So it's more how far west the dust penetrates. If it goes all the way into the Caribbean, that's a sign of pretty strong low and mid-level wind flow that basically is not conducive for an active season. So we've done a lot of analysis on this, and it's not really necessarily how much dust comes off of Africa, but how much dust makes it into the Caribbean is more important when you're looking at dust levels.
I think we call that the old Saharan tongue of the desert, reaching out
exactly,
over the Atlantic.
Yes.
All right, Jared, did you want to add a question?
Yeah. So let's look back a little bit at last year, and two really devastating storms, Florence and Michael. We're always trying to learn. What were your takeaways from those storms?
Yeah, well, obviously being in the Carolinas, obviously Florence was obviously, it had a huge impact on the Carolinas. And I think one of the things with Florence was it was a real forecasting challenge from the wind perspective. The forecast for the flooding was really well anticipated several days out. It was all the flooding was really hammered home that the flooding was going to be an issue. But the intensity was much more of a challenge. Obviously, it was a Category 4 hurricane in the Eastern Atlantic, then it weakened to a tropical storm, then re-intensified to a Category 4, and then weakened back to a Category 1 before it made landfall. Obviously, had Florence been a well-behaved hurricane and kept on moving, it would have done a little bit of damage, but would not have been nearly the storm that it was. Obviously, it was its stalling motion and the fact that basically once it went over land, it just had no place. It basically kind of like Harvey in 2017, the steering flow was very weak. So there really was nothing to push the storm aside for a couple of days, and that's obviously what caused the massive flooding that you saw in the Carolinas from Florence. And I believe the last damage estimates I saw, it's about $25 billion from Florence, which is obviously a tremendous amount of damage.
Yeah, and then for Michael, I mean, that one in particular, we've all seen the footage of homes blown off of their foundations, and it really looked like a tornado went through there. Any takeaways from that you would like to share? Because that one really left a mark.
Yeah, well, I think the thing is, after Irma and after Florence, you always had kind of the thing, it's always like, oh, those storms, it was like you had weeks to kind of get ready and the hype just kind of built and built and built. Whereas with Michael, I was on vacation a few days before Michael, and I remember looking at the models, looking at the satellite, being like, oh, great, I'll get back home, nothing much going on, the tropics are nice and quiet. And it was like Saturday, I looked at the models and was like, oh, crap, things really getting going. And, obviously it really ramped up very quickly, faster than the models anticipated, faster than, most of the forecasters anticipated as well. And that's a classic kind of October storm, is you can get these kind of really quick formations in the Western Caribbean, then they start moving north. So, you don't always have 2 weeks to get ready. With a hurricane, you may only have, in the case of Michael, it formed on a Sunday and made landfall on a Wednesday. So, most people, Sunday's, day of rest for a lot of people, so no one's really paying that much attention. And then they wake up on Monday, get to work, and they realize, there's a hurricane potentially bearing down in a couple of days. So sometimes it has to be a very quick preparation and evacuation, like we saw with Michael. The intensity forecasts were really challenging. There was a decent amount of shear over the storm, but maybe due to the current kind of like the angle that the shear was coming from, along with some other factors that may have helped ameliorate the shear, the storm was still able to intensify. And one of the things that typically happens is northern Gulf of Mexico storms typically weaken as they come on shore. Even we saw it with Katrina, we saw it with Rita, we saw it with Opal, and that's because typically your sea surface temperatures in the northern Gulf are quite a bit cooler. So it kind of runs out of steam, and you get a lot of dry air pulled off from the U.S. coast. But In the case of Michael, the water temperatures were just as warm in the northern Gulf as they were in the southern Gulf, and consequently the storms just ramped up and intensified all the way up to the point of landfall. And obviously, had Michael not made landfall, it probably would have intensified even more because it was definitely deepening right as it came on shore. And certainly, as you said, it kind of looked almost like tornadic damage, given just how intense winds were where the storm made landfall.
Yeah, I remember watching that, and you know, and remarking one about, you know, how it was deepening. I mean, I had the GLM turned on with the satellite there, and I mean, I saw the lightning flashes right at landfall. I mean, I'm pretty sure they saw lightning in the eye. You know, the storm chasers there, that somehow go into these things. I want nothing to do with that. But the other thing about that is that it was moving so fast. I mean, it was moving at a good clip. And I'm sure that helped. You know, I mean, sometimes, you know, too much forward motion often can work against it. But I mean, it just really had all the, it had all the stuff, unfortunately, and and thankfully, thankfully in a way, yeah, as you said, there was no more water. It ran out of water. It ran out of time. But yeah, you know, I saw some research recently, you know, not necessarily, I mean, it's a tweet, so maybe not necessarily peer reviewed, but, you know, these Cat 5 seem to spin up real fast.
Yeah, I mean, they can. It depends. I mean, a lot of it is, you know, Category 5 hurricanes require really an optimal environment. So they need to have very, very low shear, and they need to have obviously very deep, warm ocean water. And so you see that with Category 5. So typically, you know, most major hurricanes undergo rapid intensification at some point. And there's various definitions, but usually it's 30 knots, or say 35 miles an hour in 24 hours is considered rapid intensification. And most major hurricanes undergo rapid intensification. I don't have the number for Category 5s, but I'd venture to guess it's pretty much 100% of Category 5s at some point undergo rapid intensification. And you can, you know, depending on which basin, they can sometimes, you know, rapidly intensify right on your doorstep. And obviously those are the ones that really cause concern. In the case of Michael was rapidly intensifying, but its intensification rate was never like extremely high. It just was that it never took a break. Basically, from the time it formed to the time it made landfall, it was intensifying at about 30 to 40 miles per hour every 24 hours, right up to the time it made landfall. So it was just a very, very consistent like low grade rapid intensifier the whole way up. Normally these storms take a break, and Michael had about a 6-hour break in his entire lifetime. It just kept going. And normally storms take longer pauses than that, but that storm just for whatever reason, you know, really kept going. And I'm sure there's going to be a lot of modeling studies coming out on Michael and exactly how it was able to intensify despite, you know, fairly high shear near the system. And there may have been basically the upper level low pressure areas near it may have helped to kind of ameliorate the shear that Michael was actually experiencing.
So that's actually a great segue into what I was going to ask you about rapid intensification. Let's talk to that a little bit. Now, we saw what happened with Michael, and so we know about the Gulf eddy. We know that can be a factor in it as well. But other areas of the ocean, what sort of factors, you know, create rapid intensification? And for our listeners out there, what is rapid intensification? What defines that?
Yeah, so rapid intensification, you know, there's various definitions, but the classic one is that a storm intensifies 35 miles an hour. Its maximum winds intensify 35 miles an hour in a 24-hour period. So that's kind of considered rapid intensification. But you can get storms intensifying much, much faster than that. For example, we had Hurricane Wilma, which intensified, I forget what the exact number is, but like 80 or 90 miles an hour in 24 hours. You get these really, really, really rapidly intensifying tropical cyclones. But in general, basically, the environment you look at to get a storm to intensify, you basically look for an even more conducive environment for it to rapidly intensify. So typically it's very warm water, because that's the hurricane's fuel source. Often it's not just the fact that the ocean surface is warm, but that it's warm several hundred feet down in the ocean. So the storm can rapidly intensify and not churn up cold water underneath. You want very low shear, so the change in wind direction with height you want to be fairly low, so the storm can stay vertically coupled. You also want lots of mid-level moisture. Basically when a hurricane is when you get the thunderstorms and hurricanes, they're bringing in air from the surrounding environment, and if that air is very dry, it tends to choke off the thunderstorms. It forces downdrafts, dries things out. So you basically want warm, very warm water, low shear, and lots of moisture are kind of the three fundamental things. But even when you have all those things, it doesn't guarantee you're going to get rapid intensification. The internal structure of the storm also has to be such that it can handle those environmental characteristics in the right way, and that is a more nuanced process, which I think is why both statistical models as well as the numerical models still have trouble really forecasting this rapid intensification. Is getting both the external factors right, but also the internal factors of the storm itself.
Yeah, that can be rather surprising sometimes. It just, we just watching that thing sort of a juggernaut into the coast, which brings up our next topic, which is behavior at landfall. We watched as Florence weakened heading towards land, and we watched as Michael grew as it headed towards land. So talk about relationship to storm landfalls, and also maybe some of the mechanical features that may draw this storm a little further north versus what Florence did, which was when it went west across the state.
Yeah, so I mean, a lot of what happens when the storm is coming on shore is, obviously what are the water temperatures like right before it makes landfall? Is a storm moving slowly? Is a storm moving fast? A faster moving storm is generally, as you get closer to the coast, the waters typically obviously are shallower, and so you can churn up cool water a lot easier. But if the storm's moving relatively quickly, like Michael, it just kept on trucking. It didn't really have time. It was moving fast enough that it didn't really have time to churn up any cooler water that was there. Whereas a storm like Florence was coming along fairly slowly, so it had more time to kind of churn up some cooler water and tend to weaken a bit more as it was coming on shore. Florence also did encounter quite a bit of shear as it was approaching land, which obviously took some of the stuffing off. But even if Florence hadn't stalled, you certainly would have still seen quite a bit of damage, because Florence was a fairly large in size storm, and it did have quite a bit of storm surge associated with it in parts of eastern North Carolina. And so even if Florence had been moving a little faster, you certainly still would have seen some storm surge damage, just given the fact that it was a fairly large in size storm as it was coming on shore.
And the other unique thing about these storms is the NHC's track guidance is getting better and better. And they did a phenomenal job. I think they got the Florence landfall within, what, a mile or two?
Yeah. Yeah, definitely. And so, the track forecasts are getting better and better. And Chris Lancy at the Hurricane Center has even published some stuff saying, kind of saying, maybe we might be getting about as good as we're going to get with track forecasts, because there's always chaos that you're not going to be able to predict 5 days out exactly where the storm is going to go. So I think at shorter ranges, maybe we're getting about as good as we're going to get. Longer ranges, certainly there's stuff we can do. There's talk about extending this track forecast out 7 days for storms like, say, like Irma, that are out there for a very long time. And that's just a testament to the fact that these numerical models are getting better and better. But even though those forecasts are getting better and better, the intensity forecasts, while they're improving, are improving at a slower rate. And I think the track in general for a numerical model is fairly straightforward to predict, because hurricanes move like pebbles in a stream. So basically, if you can forecast kind of the mid-latitude weather patterns, it can forecast how the storms are going to track. But getting the intensity forecast is much more challenging, because it's not just getting the kind of the large scale environment correct, but it's also knowing what's going on internally with the storm.
Well, somebody has to forget to unmute their mic, and so I mean, I'll take that fall for Scotty tonight. So talking about tropical cyclones and climate change, the conventional wisdom being that warming planet, warming waters, stronger tropical cyclones. Curious on your thoughts around that, and what we might be able to look for in the coming years, what we might have to quote unquote look forward to. Not sure anybody's looking forward to it, but anyway, thoughts on that?
Yeah, so when you look at the observations, the damage from tropical cyclones has gone through the roof in the U.S. compared with, say, what it was 50, 100 years ago, just adjusting the damage for inflation. But the primary driver that we've seen of the increase in damage in recent years is simply due to the fact that there's a lot more people along the coast than were there, say, 50, 100 years ago. Hurricane makes landfall in an area where no one lives. It does no damage to structures because there's no structures there. So you see that with tropical cyclones. That we think the primary driver that we've seen of the increases in damage to date is mostly just due to changes in population along the coast, along with the fact that we're more affluent in general than our parents and grandparents were, which is a good thing, but it increases basically the exposure when these storms come ashore. If you look at, say, landfalling hurricanes in the U.S., there's really been no trend. If anything, it's slightly downward since the mid-19th century, but there's no significant trend. But a lot of the argument isn't necessarily that we're going to see more hurricanes or that we're going to see more named storms. It's that the storms that form may be a little stronger in the future because with a warmer ocean, that provides more fuel for the storm. It's not a perfect one-to-one relationship though, because when you warm the ocean, you also in global warming warm the atmosphere. So that takes a bit of the edge off because it changes the stability profile of the atmosphere. But you also have to deal with shear questions and whether we're going to have more El Ninos or not. If you have more El Nino events, while it knocks down Atlantic hurricanes, it actually tends to increase global tropical cyclone activity because it really ramps up storm activity in the Pacific Ocean. And the Pacific Ocean is really, if you want to get an active season, is where you get the most bang for your buck is in the Pacific Ocean, since it's obviously a much larger ocean, and the conditions in the Atlantic, you get more shear, and you have drier air in general in an El Nino. In the Pacific Ocean, you tend to actually have less shear and just overall more conducive conditions for storms. So there's those kind of questions with storm intensity that we're dealing with. But I think a couple things that we are probably know better are, just with sea level rise, a few inches of sea level rise to a foot might not sound like much, but in very low-lying areas, that can mean increased inundation when hurricanes do make landfall. Also, too, with a warmer atmosphere, it can hold more moisture and consequently can cause potentially more rain with the warmer atmosphere since it can hold more moisture. One of the big questions is our storms slowing down? And that's a really kind of a big topic of debate right now is, are hurricanes slowing down? And I think, there's a paper that's been published that says storms are slowing down. I think it's it may be somewhat of a nuanced process. And the question is, if storms slow down everywhere, if storms slow down enough over water, that's actually a good thing because a slow-moving storm over water turns up colder water that tends to weaken it. Whereas if you slow a really fast-moving storm down, that actually is better for the storm, worse for people in its path because it allows storms that are going really quickly tend to not really be able to develop a very strong, well-organized circulation just because they're kind of outrunning the center of their own circulation. So they have a hard time getting going. So there's a lot of questions with our storms really slowing down. I think maybe a little bit, but I think it's still too early to say exactly how much of an impact that's going to play. But certainly the warmer atmosphere could certainly exacerbate rainfall.
Yeah, and it's interesting you mentioned the Pacific because the Pacific. I mean, in 2018 was a very active year in the Pacific, both in the Eastern and Central Pacific in particular. Several typhoons. We had U2 come through and just absolutely rock Saipan there, and the damage there was extensive, and it still blows my mind how quickly they were able to bounce back. But so I mean, it's a very the Pacific definitely being lit up like that is definitely something we saw last year, and I think it'll carry forward pretty well. So Shay is going to jump in a little bit. He's got a little bit of he's got an ace in the hole.
All right.
Yeah. Couple of terms for meteorologists. We use TCHP, which is tropical cyclone heat potential, and also ACE, which is accumulated cyclone energy. I know that you do a lot of great stats and historical analysis based on these numbers, and if you'd like to speak to those, how we get to higher amounts of tropical cyclone heat potentials, and what does ACE mean for the meteorology world?
Yeah, so tropical cyclone heat potential is basically how much heat basically a theoretical hurricane can tap. So the hurricane, moves over the ocean surface, but as it moves over the ocean surface, it has very strong winds that mechanically mix the ocean, and so it'll start tapping ocean water that's deeper down in the ocean. And so basically the idea is that especially for slower moving hurricanes, you need lots of tropical cyclone heat potential, not just the water temperatures at the surface, because as the storm if the storm is moving fairly slowly, it churns up water, and so if it's bringing up cooler water, it'll tend to weaken. So you can have areas where you have very warm surface temperatures, but there's not that much heat potential. There's other areas where you have very warm waters, but a lot of heat potential. And Dr. Gray used to always call these areas basically areas where hurricanes can quote unquote cook. One is the Western Caribbean. That area tends to have very, very warm waters and very deep. So you can see these kind of low-level cyclonic circulations called gyres that develop, especially in, say, like October. And they can basically kind of cook down there for several days before they spin up. Another area is near the Bahamas. A storm like Joaquin, even though it was moving very, very slowly when it hit the Bahamas, there's a lot of very deep, warm ocean water there, so it really didn't weaken as much as you normally expect when a hurricane is moving that slowly. When it comes to accumulated cyclone energy, or ACE, basically it's an integrated metric that takes into account the frequency, the intensity, and the duration of storms. So you basically take the maximum winds that you have at any particular. So the Hurricane Center puts out advisories every 6 hours. So every 6 hours that the Hurricane Center puts out an advisory, you take the winds and you square them, and that estimates the kinetic energy generated by the tropical cyclone. So a storm like Hurricane Irma, which was a very, very long-lived major hurricane, generates a tremendous amount of ACE because you're squaring very high quantities over and over and over again and summing them up. Whereas a storm like Hurricane Michael, obviously it was very, very intense, but it didn't generate as much ACE because it was a very short-lived storm, and then it basically formed, rapidly intensified, then made landfall. So ACE gives you kind of one number to generate, to kind of give you, basically gives you one number to kind of assess overall how active a season is. Sometimes the number of, especially the number of storms, but even sometimes the number of hurricanes might not be the best metric, because you can have storms that are very long-lived and very intense, or you can have storms that are much shorter-lived. So you can have a season with, say, like 2013, where we had 14 named storms. So that's a pretty high number, a little more than the long-term average, but only 2 hurricanes. It was actually a very, very anemic season. Whereas 2004 had only 15 storms, so just look from that number, you know, just a little bit more than 2013. But we had 6 major hurricanes that year, and obviously a tremendously active season, but also devastating season from that perspective.
Okay, any other questions from the panelists? I might have one more up my sleeve. I'll give it to you guys first if anybody has anything. All right. My final question for the Atlantic Basin. What are we looking at for sea surface temperatures? We look at different oscillations. We have the North Atlantic Oscillation. We have bodies of water that are cooling, heating. We have the monsoonal trough along the equator, the equatorial Atlantic. And what are we looking at for this summer possibly being? Are we looking at a stronger monsoonal trough that would generate more off the African coast, or is it too early to tell just yet?
Yeah, so right now, we often kind of look at it through what's known as Atlantic meridional mode, which effectively is sea surface temperature gradients between the northern tropical Atlantic and southern tropical Atlantic. So when that is positive, that means the northern tropical Atlantic is warmer relative to the southern tropical Atlantic, and that tends to favor a northward shifted monsoon trough, which basically tends to be conducive for hurricanes because it weakens the low-level wind flow. It basically helps to create kind of low-level spin that can help spin up these storms. It also tends to be a more conducive environment for the thunderstorms, which are the building blocks of the tropical cyclones. Right now, that index looks to be a little bit negative. It was strongly negative in, say, March and April, and it's come back to more near normal. So that's certainly something we're going to be obviously monitoring very closely. You also mentioned the North Atlantic Oscillation. That was generally very strongly positive throughout the winter. And basically what that does is it basically drives very strong winds across the tropical Atlantic as well as in the far North Atlantic. So you end up with kind of a tripole pattern where you have very cold up by Greenland, very colder, a little colder than normal in the tropical Atlantic, and really warm off of the East Coast. Over the last few weeks, that pattern's actually reversed. And so we were seeing kind of a relaxation of that really strong tripole pattern. So right now, the water temperatures in the far North Atlantic are still somewhat colder than normal. The waters off the East Coast are still warmer than normal, but not as warm. And the tropical Atlantic has warmed up to about near normal at this point.
Very good. Well, thank you for that analysis. And if there aren't any other questions from our panelists, we'll ask you, how do folks follow you? What's the best way, best mode through social media to follow Dr. Phil Klotzbach? Let us know.
Yeah, so our project, probably the best way to follow me is via Twitter. I'm at Phil Klotzbach on Twitter. So I try to post content on there pretty much every day during the hurricane season, and obviously when there's impending storms, I post quite a bit. Also, you can go to our forecast website, which is tropical.colostate.edu. The website has all the forecasts, links to my Twitter, and then publications and other stuff there. So those are the 2 best ways to keep in touch with me.
All right. We thank you very much for coming on tonight. It's always a pleasure to have you on, especially just ahead of the beginning of the hurricane season, which starts June the 1st and lasts through November the 30th. With that, I'm going to turn it over to James. I think we're going to be hopping over here in just a minute to our storm chasers out west, unless we're going to do a little round table first.
No, that's exactly what we're going to be doing, Shay. Thank you so much, Phil, for that great analysis. That's right, hurricane season starts this Saturday, and so it's really helpful to not only recap the last season, but really know what's going to be coming up next. We appreciate his time. If you have any questions, comments, or other thoughts that you want to share with Phil or us here at the panel, we do have a new feature that I forgot to mention at the top of the show, but if you're one of our podcast listeners, check out the link in the show description. You can actually send us a voice memo now, and so you can call into our show because we'd love to hear from you. And when we say that, we literally mean we would love to hear from you. So you can always check us out on Apple Podcast, Google Play, Stitcher, TuneIn, and happy to announce that we are now up and running on Spotify. Coming up on the 9 o'clock hour, we're going to go live to the Carolina Weather Group chase vehicle. It's Chase Week here at the Carolina Weather Group, and last check, they're in Texas checking out some storms. But before we find out what they're doing today, let's take a look back at what the group was up to yesterday.
Yeah, Detroit Airport. So we just got off our flight from Greenville, South Carolina. So we got the whole panelists here. Let's kind of talk about, Chris, you've been looking at the severe weather today. What's our game plan once we get in Denver?
We're going to check all the meso analysis, surface analysis, see what everything looks like, and formulate a game plan. We've got 2 little locations I'm thinking about, and see which one looks the best.
Well, okay, so I think we're live here. Scotty Powell, Evan Fisher, Chris Jackson up front, driving. Literally, Evan, we landed about, I don't know, it was like 11:30. We had lunch about 12-ish, and we're already placed in a tornado watch.
So we're chasing this just east of Denver. We can see a wall cloud from here. It's a pretty heavy precip, definitely some big hail in there. And Chris is trying to get us in position to get just on the east side of that.
There has been a tornado watch issued for this area. You can see these. We had some mammatus clouds just a little bit ago. All right, guys, so we are just north of, I think, Fort Morgan. Is that where we just came through? We're watching a tornado warned cell right now. This is the cell that's tornado warned right now. We've noticed a little bit of an uptick in lightning over the past couple of minutes. So our goal is to kind of get north of this cell and try to get a better view on it. Several suspicious areas, several lowerings, but we have not been able to visually see anything yet.
Looking at the exact location of this storm right now, this is exactly where the HRRR, the HRRR, is forecasting a very high resolution weather model. It was forecasting a single cell to pop up right where this is and just truck northeast all the way through the Nebraska line.
One thing we've avoided, Evan, was the hail.
The only way we're getting hail right here is to keep rising around the meso.
So you can hear the tornado sirens are going off here in Sterling, Colorado. It's the first time I've ever experienced tornado sirens. And here's the tornado warned cell right here.
Across the field. Right there, look. It's so small.
Yep. There's your tornado right there. Yeah, you can hear it. It really does sound like a whistle. Large. Scotty Powell, Evan Fisher, Chris Jackson, somewhere around. There he is.
Yep.
He's coming in. So we're going to give you a little recap of today. Today was our first day chasing. We got into Denver, Colorado. I think it was around 10 o'clock this morning. And we got on the road about 11:15-ish, 11:30.
Yeah.
And by 2 hours into it, we were already seeing tornado warning sails come up. And I don't know the official count, but
It's going to be somewhere like 7 to 10 tornadoes today.
Yeah. And these weren't the big wedge tornadoes that you may see on TV, but they were pretty cool to see. A lot of these tornadoes was out in the middle of fields.
Yeah,
so
absolutely.
We didn't have a lot of like houses and property damage.
Yeah, I haven't even seen anything other than like some tumbleweeds destroyed today, but still get to see this weather just makes it all the more better.
So it was cool. Chris, you were driving today. We were in the midst of a hailstorm.
Yeah.
And it was probably about 2 inches of hail at one time on the ground.
Yeah. The Denali that we have, it's got four-wheel drive, and the only way I could get any traction on a paved road was using four-wheel drive because the hail was so deep, and it was actually pretty impressive for me. Like I drove fire trucks for over 10 years, and having to do that was like, well, dadgum, I got to use some skills.
It was almost like it was snow.
Yeah, it was.
It was like snow. A little bit about how the structure's formed.
Yeah, absolutely. If you guys can see behind us, if you want to take it up, we got a nice big elevated. It was a low precipitation supercell, but it's starting to get a good bit of precipitation in it now. Classic mothership type structure, and what happens is, with the cold air aloft and the low level jet coming in here, it helps to really sculpt this storm up. And if you guys can see, it looks like a wedding cake. It's got layers on it, and as you go up, you can see some of the fingers going into it, and that's some of the elevated moisture is helping feed the storm. But we've been watching this storm for probably 45 minutes now.
But anyways, it's been a really good day, and I'll be honest with you, tomorrow and Wednesday look to be just as good weather-wise. Tomorrow it may even be a little bit more severe, to be honest with you, in portions of Kansas. So that's where we plan to go next. So we're going to go ahead and log off here. It's pretty chilly, and I think we're all a little tired. We didn't really sleep at all last night, to be honest with you. It's been a very long day. I don't even know what day it is, what time it is. So anyways, we're going to go grab some dinner and probably spend the night somewhere in Nebraska or Kansas. And we'll be back with you tomorrow to let you know where we're going to be chasing.
And not only will they be back to let us know where they're chasing, but they're back with us right now live from Texas. Let's welcome back into the Carolina Weather Group Evan Fisher, Scotty Powell, and just out of frame is Chris Jackson driving the vehicle there. So guys, we just watched your video from Monday. You saw what looks to be a lot of dust devils, but I understand the action really heated up on Tuesday.
There was, honestly, no one else out there while we were watching the first 5 or so tornadoes. And even when we were chasing the last 2, we only saw 3 or 4 other chasers. So it was really empty in Colorado.
It was, and we saw the video you were playing. We talked about that day was supposed to be a big hail threat day, and we really didn't see any until we got into Sterling, Colorado. And Chris, I'll let him talk. It was like driving in snow once we got out there.
Yeah, absolutely. We're coming to Sterling, Colorado, on the south side of Sterling, and as we were doing that, the storm really wrapped up a tight circulation, went tornado warned, had a very, very tight couplet, and I've never seen scud literally coming across the ground into the storm at probably 50 to 60 miles an hour and then getting vertically lifted. At that point, we just got wrapped up in just some heavy RFD, probably 60 to 70 mile an hour winds. And soon before we knew it, we were driving in probably 2 to 3 inches of hail accumulation on the road. I actually had to put this Denali here in four-wheel drive just to be able to maintain any kind of control on the road because it was so slick. But after that, we encountered some folks that decided to park under an underpass, and it blocked our way out of this town. There was only one way in and one way out of town, and had people parked under the overpass, and that really hampered not just a couple storm chasers trying to get out of there, but they were also putting themselves in danger because that was a really strong circulation. And I feel pretty sure there was a tornado wrapped up in there, just because we saw the fire department going to check for damage and stuff. But just if you're watching this, hear this, please don't park under overpasses. It's dangerous for everybody.
Yeah, Chris, we're looking at some of that video right now. I've turned down the audio a little bit as you're advising drivers not to be performing the actions that they're taking, because not only is that an unsafe place for them to be, but also, like you said, hinders everybody else in the traffic flow there. So we're taking a look at that right now. Where are you guys right now? Where are you heading? What's the plan for you're 2 hours behind us, so
Same town.
Come again?
Yeah, I didn't know if you guys had lost our audio. Another thing with that storm was there was a train that was in Sterling, and there was only another way out, and the train had stopped because of the tornado warning, and so we were kind of just trapped in that location for a little bit.
That's why we had to go up into the hail in order to get up and out of that city, to go up to the next town over to get onto the interstate again and get out ahead of this storm.
And then I guess we can go talk about yesterday's tornadoes. We started off in Oakley, Kansas, which is between Hayes and Junction City, I believe, be the two major city, or not major, but pretty big cities. And we started out, we looked, and I think at one point where we were at, under an enhanced to moderate risk of severe weather with all modes of severe weather possible. And Chris, like we said, Chris is the expert out here. Evan, we've not done this before, so we were going off of Chris's leanings, and it turned out to be a good thing. Chris, you didn't really want to chase the Kansas City, Lawrence, Kansas populated area because of the possibility of seeing a lot of HP, high precipitation supercells.
Yeah, that's right. Looking at the setup, you had a moisture stream that was coming off the Gulf with a really, really, high amount of moisture coming into those storms. And as they developed, you could just see the moisture on radars. It was just going into the first storm that developed that put the half-mile wide wedge down. So, just looking at the environmental parameters going on, I chose the triple point back closer to Hayes, which we ended up having to backtrack about 80 miles, but there was a lot of low-level CAPE, in CAPE is thunderstorm fuel. At the surface, there was a little over 5,000 joules per kilogram of CAPE, which is an extraordinarily large amount of energy for thunderstorms, and that's what tornadoes love. They love that big, fat CAPE in the low levels of the atmosphere. Combine that with a retreating warm front that allowed for a lot of, wind shear, if you will, and some low-level helicity. The first storm that formed put down a funnel within 20 minutes of going up.
Was that the Waldo storm?
Yeah, that was the Waldo storm. It put a funnel down actually in Hayes, and it was a really brief funnel. But we intercepted the storm. Right as it was getting ready to do its thing, and I happened to look up and notice the ground circulation. There was no evidence of a funnel whatsoever, and then it quickly went multi-vortex, and then we had a half-mile wedge within 4 minutes.
Yeah,
we're taking a look at that video right now. Go ahead.
Yeah, and Evan, that storm, we were freaking out because we had never seen these. You only see these on TV, chasing and stuff. And this was a really large tornado, and it was crazy because we saw all the steps. It was a multi-vortex, and then a cone, and then a stovepipe, and then actually roped out to this little tiny pencil. I sent some pictures to James. I don't know if he got those, but It was a crazy storm, and then we watched that storm continue to track, and we've got just the preliminary data from the National Weather Service in Wichita, Kansas. It was an EF2, and this, I think, was on the ground about 24 miles, and then we picked it up as it was going through Luray and Tipton.
Yeah. So like I said, we actually thought that it had split and died off halfway through, but it must have just been wrapped up in the rainfall because we couldn't see it. But it turns out it didn't die out halfway through, and it re-strengthened as it went through Tipton. We actually came across the damage path. There were some tractors, some farm equipment that had been tossed and mangled pretty bad, as well as some power lines that were down over the road.
And it missed the house. I mean, it was about maybe 100 yards.
Yeah, and the house had no damage at all, not even little twigs down in the front yard. It's pretty unreal how it can come that close to a tornado and not see not even the slightest bit of damage.
And that was kind of like made it become real. It's like the first day we saw tornadoes, it was just out in the field. There was no damage, but this is actually where we saw damage. And it's crazy how, it's not really crazy, but it's just something we've not experienced. The police blocked the roads out here. They block the roads. They go driving through towns with their sirens on, telling people about the tornado warning. The storm sirens were going off.
Yeah.
It's just things that we don't experience in the South.
Yeah, it was unreal, and it was honestly, like you said, scary at first. We came upon that damage, and our first thought was that it was a car. We thought it had been a car, possibly a storm chaser, or someone else driving from locally that had been tossed. And that's something that Scotty and I heard first aid background. So they're much more well trained to deal with that kind of stuff. But luckily, there were no injuries from what we saw. And I don't remember reading about any injuries on the damage report.
Yeah, and another thing was there's this huge rainbow as this tornado was ongoing. So you had the tornado, and then just off to the right is this huge rainbow that just stretched out across the sky. We continued on a dirt road. We got some video of that we sent to you. And we were trying to go to, I think it was Concordia, I believe was the name of the town, and Belote, I think was where we were driving through town and had the tornado sirens going on. And that was just a wild experience in itself because legitimately we were chasing tornadoes. And all through this, we saw the University of Oklahoma's radar truck out, and we saw Kermit.
Yeah, and for those of you who don't know what Kermit is one of the two airplanes that we saw at the Hurricane Hunters 2 or 3 weeks ago now, I guess. And it was pretty cool. We probably saw Kermit fly in and around the storm above our heads 10 to 15 times, which was pretty cool. And like you said, we've seen people from all different areas of tornado research, from Oklahoma University, the University of Oklahoma, to Texas Tech, the Taurus Project, Embry-Riddle. So we've seen just about everybody. It's been awesome.
And Melissa, I know you're on the Western Kentucky Storm team was out there as well. We saw those. But Chris, you're the aviation guy. You monitored Kermit. How many miles did he fly yesterday?
I'm not sure on the actual mileage that Kermit flew, but he took off from Salina. Relatively short flight to get to the storm, maybe only like 30 nautical miles. But Kermit flew for a little over 6 hours nonstop on this same group of storms. It was 3 storms he flew for 6 hours, and right at 6,000 feet. So every time he would come over, all you hear is the dead quiet of the open plains with a P3 and a tornado in front of you. So that was for an aviation guy like me, that was pretty awesome to see.
And another thing I want to talk about, and then I know you guys have some questions. We always hear this myth or rumor when people are interviewed with tornadoes, they say it sounds like a freight train. Well, we actually experienced that Monday and Tuesday. I didn't think it sounded like a freight train, but it was almost like a whistling sound, like you could hear it as it was starting to wrap up around you. And Chris was also showing us there's like a clearing right before the tornado developed.
Mm-hmm. Yeah, we saw that clearing right before we got all embedded in the hail and the potential tornado, like Chris was talking about. Some of the other tornadoes, the ones in Colorado as well as the ones in Kansas, we're pretty far away from the Kansas one. So it definitely could have been that what we were hearing was the whistle from the tornado. And it's also kind of hard to differentiate between that and power lines. Because unfortunately we were stuck near power lines and they would whistle as well. But we could definitely hear something off in the distance that was pretty neat. And obviously a nice goal to see.
All right, back to you guys. If you have any questions, we can ask them or answer them.
Yeah, let's bring in the panel and see what other thoughts we have on this evening. I know folks have been following your journey.
Yeah, I was going to ask, what looks like our ridge is going to break down in the southeast over the next few days. What does that mean for your area? Is there still going to be continued warnings and severe weather out there, or what are we looking at from the Gulf of Mexico moisture?
Hey, Shay, really, after tomorrow with that ridge breaking down, the flow across the Midwest is going to become a lot more zonal and less amplified. And so, tomorrow we're going to play the dry line out here in West Texas. There's a little spot out here, Fort Stock. It's kind of world famous, especially in 2019, for producing these prolific supercells that are by themselves. And, after that, it's going to be really slim pickings. And, I'm not sure if we're going to see anything else, with the flow off. But if there is anything, maybe the Cheyenne Ridge with some upslope flow just northeast of Denver later this weekend or maybe Monday. Some of that terrain induced or the Palmer Divide down into southeastern Colorado.
Yeah, that's a good point. I was going to ask you about Colorado, actually. That was going to be my next question. Some of that zonal flow heading back down slope that can sometimes produce some of those severe cells. But yeah, that sounds like it's really fun and interesting out there, learning a lot. It's a whole different beast out there. We always tell folks in the southeast our tornadoes are much different, and the storm cell setups are much different than the west. If you want to speak to that a little bit.
Right.
Yeah, and we're hoping that we're going to get a day or two in Oklahoma City and kind of, maybe head out to the Storm Prediction Center. We know a few people there, and see if we can get in there and just kind of mess around a little bit and do a little sightseeing over in that way too. Check out the Twist-X Memorial in El Reno. And so, yeah, but it's been a good day. It's been a long drive today. I can't remember how many miles we've been on the road today. 570 miles and counting. So it's
Total of roughly 2,000, just short of 2,000 now. Just short of 2,000 miles in 3 days.
And we can see Midland, Texas out our window now.
Hey, I'll see. Can I flip my camera around? No, but I can just turn it around manually.
If you guys go between Midland and Odessa, you may get a good view of the KMAF WSR 88D. It looks like it's. I was looking at it on radar scope. It's like right along the interstate there. So you might see a radar. I don't know. Kind of cool.
That would be awesome. I know we had eyes out for the University of Oklahoma radars earlier. Couldn't see them because it was so rainy.
Yeah, we're looking at some of that video you guys shot in Kansas yesterday of those mobile Doppler radar units. Looks like something right out of the movie Twister. Well, we are glad, appreciative of all the video you guys are sending back, that you guys are safe, having a good time, but doing this very responsibly as well, too. As folks are following us here on Facebook Live, YouTube, Periscope, and Twitch this evening, tell them where they continue to follow your trip. It goes for another week or so.
Yeah, so we're doing a lot of things. You can follow us on the Carolina Weather Group, Carolina WX Group on Twitter and Facebook. We've been doing some Facebook Lives. Evan's been doing a lot of stuff with our Instagram platform. And you can also follow us on Twitter at ScottyPow_WX.
At eFisher828.
And then Chris has got
At Chris Jackson SC.
And so between the Carolina Weather Group and our individual Twitter pages, you can keep up with everything. And it's not all storm pictures. Evan and I got us a sweet picture with some cows last night.
Oh, yeah. We got some beautiful pictures with the cows. They're really interested and curious about us, as well as just keeping up with our general travels, because where we're going is a big part of what we're doing.
Yeah, you'll probably see some big old wind farms today. We got some coyotes howling last night.
Yeah, that was near the cows. Hopefully they weren't going for the cows.
So, but yeah, we'd love for you to follow along, and even on those quiet days, we'll still do some social media stuff and stuff on our platforms. So I think we're all hooked on this. We'll probably have to do this again next year.
Oh, yeah. This will be a repeated thing. Absolutely.
Make sure to eat at Waffle House via Pat Warner. Mention his name, and then also Cinnabon for dessert.
Yeah, we're looking for Waffle House. We are definitely going to try to hit up our guest, Sydney Sperry from the SPIA Index. He promised us lunch or dinner, so we're going to take him up on that.
Yeah.
He lives in Guthrie, so when we get back up to Oklahoma, we'll hope to meet up with him. But we are planning to eat at a Waffle House. I think there's some in the Oklahoma City area, so we're definitely going to do that.
Well, guys, we appreciate it. I just put in our comment on our live streams here. If any of our viewers this evening have questions for you, they can go ahead and type those in right now on Facebook, YouTube, Periscope, or Twitch. Or again, if you're listening on our podcast, you can actually call in and leave us a voice memo. We probably won't get those until after the show, but we can certainly send them along to the Chasers and have them get back to you and talk to you a little bit more about what it is that they're up to if you have any questions about what's going on. Luckily, as our three panelists continue to cruise around the Central Plains, things back here at home have remained relatively calm in terms of severe weather. We started off this broadcast an hour ago with a severe thunderstorm warning just north of Interstate 85 between Raleigh and Greensboro, but that is now gone and out of the picture, and all that remains is the heat. So we will continue to monitor along the chase that's going on right now, guys. But I think we're going to move over here to Melissa Griffin and talk a little bit about the heat. But Scotty Powell, closing thoughts? Yes, please.
Yeah, I got something. You were talking about the heat.
Yeah.
Evan and I, we've been wearing coats, hoodies. It's been cold out here. I mean, today, right now, it's like 78, but for the most part, it's been in the 50s and 60s where we've been. So all that cool weather we've experienced, you guys enjoying the heat, we could actually use a little bit of that warmth.
I probably can speak for most of the panelists and our listeners that we would gladly trade you some of that cool weather. Because we have had one just amazing heat wave take over the last part of this the month of May here in the Carolinas. Just to kind of go ahead and roll into that, we've had some stations that have set some pretty substantial records. For example, our stations in Florence and in Charleston have set their all-time record high maximum temperatures for the month of May. 101 in Charleston, they actually hit it today and yesterday, and 102 degrees in Florence. So those are now the record hottest temperatures for the month of May at those particular locations. And, along with that, individual daily records have been broken. I want to talk about Charleston first. Charleston, for the last 4 days, have recorded maximum temperatures at or above 100 degrees, including those 101 values just today and yesterday. And just as you can see, they not only broke the records, they smashed the previous records for those days. But this 4-day consecutive streak at Charleston, it comes in and it ties another 4-day streak that happened in July of 1986. The longest streak on record at the Charleston location that goes back from 1938 is actually 7 days, and that also happened in July of 1986. So, I mean, we are talking about a pretty significant, heat wave that was happening in the Charleston area. Other stations around just a couple of different stations here in South Carolina. So, Columbia, for example, we've had record high temperatures, smashed 101 yesterday, 100 degrees officially today. Tied multiple record highs since May 24th. So, you're talking almost a week of temperatures that have been pushing the 100-degree mark. Same thing for the Florence area, with that 102 degrees that we actually saw just yesterday. That is now the hottest temperature on record there. Again, multiple records that have been tied, broken, smashed in some cases. The only place that really hasn't had any records broken is going to be up in the upstate. So our station up in the Greer area has tied multiple records. They haven't broken any records in that particular location. But still, I mean, upper 90s in that particular area is significantly hot. And with that heat, we've also had no rain. So the precipitation, we haven't seen areas, we're talking about some locations that haven't seen rainfall, measurable rainfall, since the middle of May. It looks like this could actually be the driest start to a year in the Charleston area. They've only recorded almost 7.5 inches, and that's since the beginning of June. You're looking at rainfall totals and that rainfall deficit total that's pushing, I think it's like 8, almost 10 inches in some portions of the low country. The only areas in South Carolina that are still kind of above normal for the year are in the upstate, and that's because we had a really wet January, February, and into March. But since April, like the middle of April, that's kind of been turned off, and they've only gotten about 2 inches of rain up at the Greer Airport since that time. So we've seen this dry out with not only the excessive heat and the lack of rainfall, but we've also had some windy conditions, and that's led to red flag warnings that have been put out. So looking at an increase in the fire danger, we actually just yesterday had a 200-acre fire that closed down portions of I-20 in Aiken County. There were 2 fires this afternoon that Horry County Fire and Rescue were on. I think they were around the 501. I can't remember where the other one is. So that has actually put a ban. The commission has put out, the South Carolina Forestry Commission has put out a ban on burning. I mean, as you can see on the graphic, these are all of the fires that, the X's means that they've been contained. There are some active fires that they're still currently working. So we're really kind of in, with underneath this ridge, while it has funneled all of the severe weather through the plains and into the Midwest and even portions of the Mid-Atlantic. We've just been stuck under this ridge, and it has just given us some oppressive heat. And I know it's had some impacts down in the Charleston area. I think Jared and I were talking the other day. There was something with the bridge down in that area, right, Jared?
Yeah, the Ben Sawyer Bridge, which is famous during Hurricane Hugo for being stuck open and damaged there, it couldn't close. It couldn't close because the steel had expanded due to the extreme heat. So that bridge was shut down. The Ben Sawyer connects Mount Pleasant to Sullivan's Island. And on Memorial Day, when you have lots of people at the beach, you can imagine how wonderful traffic was that day. Suffice to say, not very good. They did get it repaired. They are monitoring it. But at one point, they were thinking they're going to have to bring in a fire truck to spray water on the bridge itself to get the steel to contract again after having expanded due to the extreme heat.
Yeah, and those are just, that's just another example of some of the impacts that this prolonged heat has had. I mean, not only are you looking at agricultural impacts, drought impacts, human health impacts. I'm not sure of any particular numbers, but with all the tourists down at the coast this past weekend, just the record amount of heat, if you just having to be prepared for it to handle that, it's rough. But I mean, luckily, as our team mentioned earlier, we're looking for this pattern to break down. We're looking for the ridge to kind of give way, and hopefully that will give us some relief. Now, we're not talking about the 60s and 70s that our guys are experiencing out in Colorado right now, and Texas, but we are looking for at least a break from these 100-degree days.
And Melissa, we're in moderate drought here, right? So we're borderline severe. I'm not sure what the drought monitor is going to come up with tomorrow, but with no rain, we may be elevated to severe. I'm just not sure yet.
Yeah,
we did see a few little spotty storms fire off inland along the sea breeze front this evening. Savannah got a nice downpour. They went from 99 to 80 in a matter of minutes. So hopefully we'll start to see that humidity factor coming up in the southeast as that ridge breaks down, at least the Atlantic portion of it. And we start to get a few of these spotty thunderstorms in the afternoons. And hopefully those will march towards the coastline and give us a little bit of relief there. But as we get into the weekend, like you said, I think this ridge is going to break down. We have a couple of cold fronts advancing, which may assist with that. Very little rain expected, but not everybody will get it. But we're hoping to get some relief and some cool down as well, getting down to the low 90s by this weekend.
Yeah, and I know that sounds horrible for us to say that we're excited to be getting into the low 90s.
Well, that's actually go ahead, Jared.
The problem is that tomorrow, we're going to start seeing that trend down tomorrow. Tomorrow, the Weather Service has a very frigid 98 at the airport. But the thing is that with the humidity coming up, it's actually going to feel warmer than it has when we've been setting all of these records.
Yeah, you're right. We've gotten kind of, I hate to say it because we are in moderate drought, but we got one thing with this heat wave. A lot of times in June, July, we have higher humidity with the heat indices climb up to 120, 125 degrees. I've seen it here before. And it's absolutely miserable out there with a higher humidity factor. So this has been a dry heat. We've been actually kind of blessed by that. So heat indices, I don't think they got over about 107, 108 degrees on any one of these hottest days. Maybe I don't know if today went up a little bit more, but as the humidity climbs and we get another heat wave, you'll see different heat indices that'll actually feel warmer, just like Jared said.
Yeah, and as you mentioned, Shay, the drought monitor will be coming out tomorrow, so we'll see what they actually do with drought conditions across not just South Carolina, but as James had that image up earlier, you can actually see some of that dryness from the lack of precipitation, into portions of coastal North Carolina as well. So there was a tweet from Wilmington earlier that was kind of the tale of two different years, their wet start to 2018 and the dry start that they have in 2019.
It is amazing to think about the fact that we are looking forward to temperatures only in the 90s, but they are coming soon. The 90s are coming back, everybody. They're all hip again, is from what I understand.
Hopefully upper 80s by next week. If we get a northerly wind all the way down behind the front, that would be nice to get an immediate break from it. Man, I'll tell you what, it's been miserable here.
Yeah, absolutely. And so as we told you last week, folks, stay hydrated, stay cool, wear light-colored clothing, stay in the shade, take frequent breaks if you have to be outside. I've been watching folks in my own neighborhood do a lot of work here, but I think we're about to wrap up this extended edition of the Carolina Weather Group. Don't forget to follow us on whichever your favorite platform is for updates not only on the heat and other weather news, but also our continuing chase. Let's take one more live look out there as the guys, I think, are continuing to roll into Midland, Texas. We'll pop their faces up here on the screen once again. Evan Fisher, Scotty Powell, Chris Jackson are going to be continuing their storm chase trip here for the next week or so, and you can continue to follow them right here on the platforms of the Carolina Weather Group. But on behalf of them and everyone here back in the Carolinas, I'm James Brierton. Thanks so much for checking out this episode of the Carolina Weather Group, and we will see you right back here next week.